Hello, I'm Robert Johnson, and I'm presenting my video for the physics public lectures. So I attended the very first public lecture that was offered, and the lecturer was Russ Taylor from the University of Cape Town in South Africa, and he talked about square kilometer arrays. So I basically just took notes on his presentation, and I'm going to run through them and hopefully answer all of the questions throughout that. But one thing I'd like to address off the bat is basically everything he lectured about I didn't know before, so I didn't really know anything that he talked about before, so it was all new to me. But his presentation was on a large telescope project that's called the Square Kilometer Array, and it's essentially a project between 10 different countries where the goal is to create this super telescope that can detect radio waves. And these radio waves are so important because it's the only way that we can learn about dark stuff. And dark stuff is this area between galaxies and between universes that is just really large, and there's not a lot there, and it's super cold, and it's basically the breeding ground for stars. And this area is actually growing, so as the universe is constantly expanding, the dark stuff, the area between galaxies, is growing as well. So these stars are formed in this area, and that was something that really interested me, but he didn't go into a lot of detail about it. So I followed up and did my own reading outside of class. So basically this area is so cold that gases that normally wouldn't be molecular, that are normally just singular atoms, start to clump together in molecules, just because it's so cold and there's so little kinetic energy. And then as more and more of these gas atoms clump together, it starts to develop mass, and it creates its own gravitational field. So it pulls other atoms into it. And because it's in this dark matter, or in this dark stuff, the interstellar matter, there's not a lot there. So it's really easy to pull all of the atoms, and this gravitational field grows and grows and grows and gets stronger and stronger until there's a star that's formed. And one thing that Dr. Taylor talked about extensively was radio astronomy. And this is basically an analysis of the property of radio waves and studying more about radio waves. And I had no idea that radio waves were so important and that you could only detect dark stuff or interstellar matter with radio waves. So that was really interesting to learn about. And he talked about how with improved sensitivity, you can observe radio waves that are from the beginning of time. And this project is really designed to do that. There are a couple of goals that he spelled out on the project that were to establish a history of time, to figure out what the fabric of reality is, and detect pulsars, and really look at how space-time is affected near black holes. And I thought that was amazing because I don't know anything about that. And then he also, this telescope project is supposed to look more at gravity waves and also the space-time waves, which I didn't even know existed before this presentation. And then the fourth goal that he talked about was to hopefully detect signals of other intelligent life in the universe. And one thing that I thought was really cool is he said we should have an answer by the late 2020s. So hopefully we'll be figuring that out soon. But like I said, I learned a lot of new stuff from this topic. He didn't cover anything that really I already had a firm grasp of, and the lecture aspect that really sparked my curiosity was the formation of stars. So like I said, I looked up how they were made and kind of have as much of an understanding as I think I'm ever going to have. Thank you so much.